Okay, the question is, what is a derivative? And again, I don't expect you to have everything perfect today. We just went over it on Tuesday, so let's see what we did. We have that it is equal to, there we go, equal to the slope of a tangent line. I like that. There's something I'd like to have a little bit more information on, but that person's got it. Slope of a tangent line. A few more bits of information, though, would be necessary. It's a function, very good. It helps you find the slope of a tangent line at any given point. That's more complete. It is a function, absolutely. We're going to be seeing that more and more. It does help you find the slope of a tangent line at any given point, but there's something still not there. Estimate of the slope of a line tangent to a curve, the tangent line of a curve, the tangent line of a curve of the graph of a function. Okay, we're getting the words in there. Let's just see if we can rearrange them a little bit and find out more about what that means to everyone. Slope of a linear function, the rate of change. We haven't talked about the rate of change, but that's exactly what it is. Instantaneous or approximate? Or average, we should say. Average, okay. Is that the derivative, or is that the other line that we've been drawing? So the derivative is what we call the instantaneous rate of change. The average is the secant, the segment that connects the points. We'll get into that more. Okay, the slope of a tangent line on a function at any given, the slope at any given point of a line tangent to a function. Again, what I'm picking up on some of you is that you've got the words there, but we need to rearrange them so it makes sense. The slope at any given point of a line tangent to a function. Good. I don't remember. Okay. The slope of a tangent at any given point on the curve. Okay. The slope of a tangent line. I think it helps you find slope of a curve. Those are one and the same ideas. Okay. If you find the slope of a tangent line, you have found the slope of the curve. So we really haven't explained much on that. Slope of a curve at any given point, slope of a tangent. These are, I can tell already, not enough information, but you got the right idea. Okay, so we're going to build on that today and come up with a definition that we're going to be able to use. So let me get that saved for your participation mark. And let's go into our notes here. Now, let's see, somehow I don't have my notes in here, so let me just continue to build from here. Must not have saved the work, so we're going to start. Let's see. Oh, there it is. There's our work. Very good. The slope of a graph, we talked about that. This is the function we're trying to find the tangent to. The definition, somewhere, I think we had it in here. If not, we'll go back and write it again on our definition of a derivative. Right now, for now, before we get into that, we've got this f prime, and again, I think I explained to you on the notes somewhere that that is a prime mark right there. It's not just the function f. And we probably, to be more specific, should say f prime of x, because we always want to indicate that it is a function name. We have the limit as delta x goes to 0, and delta x represents what? Now remember, we're starting with a point, and we're saying, if I have another point on the curve, and I want to get, this limit means that my second point's moving really close to my first point, and as I move it closer and closer to my first point, then that difference between the points is going to 0. What basically, in one word, what does this fraction represent? Slope. Okay, so this is the piece. This is nothing more than slope. So f of x is the output of, let's say, the first point, or a point. What does this f of x plus delta x represent? Yeah, it's another output, but the output of what point then? Yeah, Casey?
The second
The second one, yeah, the second one. So again, I feel like my goal, my role with you is as much or more interpreting the math that we have as it is to teach you new math, because again, you have all the math you need for this. We just need to understand the terminology here. Okay, now let's put it down here so that you will see it again, and I'll see if I can get this saved somewhere. It was either this class or the other class. I wrote this. A derivative is the slope. Did I give this to you guys? No. Okay. Is the slope of a line. I know we talked about it, but here's the sentence that I don't want you to memorize it, but I want you to understand what it says and be able to tell me something in your own words. A derivative is the slope of a line tangent to a curve at a point. Okay. The important words, and again, a lot of you had these in the other one, so let's just make sure that we are thinking about this. Slope, obviously. A line that's tangent, or a tangent line, however you want to say it. And this is the one that I was looking for on what you contributed. It is the slope of a line tangent to a curve, and the curve is going to be our function, f of x, and it's at a point. So we're looking at it at a point. Now, you know, when you find slope, what do you need in order to determine slope of a line? 2 points. If I only have 1 point on the curve, I got a problem, okay? And that's where the limit comes in. We are looking at only being able to use 1 point, the point of tangency, but we're going to be bringing a second point as close to that first point as possible, and that's where the limit comes in. Okay, so you don't have to memorize my words. I don't want you to memorize my words, but I do want you to understand what a derivative is, so that 10 years from now, if I've given you this little speech, 10 years from now when I meet you on the street, I want to be able to ask you. I know, Nash, my husband says the same thing. You're all going to cross the other side. Oh. And but I want to be able to ask you, because the derivative, that is the main idea. That's all we're going to talk about, except now until the last 2 weeks of the semester. And if you walk out of here and you don't know what the main idea is, that 10 years from now is when I would want to evaluate my teaching and your learning in this class. Because 10 years from now, I hope you remember this. Would I ever do that to you? We'll just stop this a moment here, and I'll tell you a little story. This is a good start. It is instantaneous rate of change. There's lots more to it, but if we can get this, we're a long ways on understanding. Okay, well, let's go on. Let's find now the derivative by the limit process. Now, some of you have had calculus before. You know all kinds of rules and processes, and I don't want you to forget those. But when we have the test next Thursday, and I say find it by the limit process, if all you do is press a button, and you can press a button on that Inspire and get an answer, or you just do the rule, I'm going to give you a point for that. But I won't give you all the points for the problem, because I need to know that we are understanding limit as well, and this is why it's here. Okay, so let's go through this. We're going to look at the derivative, so f prime of x. I highly recommend that you also do this, the slope of the tangent, because that way when you show me graphical representation of this problem and how the answer reflects back or has, you know, how it connects to this, you can then on your Inspire or on your piece of paper, you can also identify the slope of that tangent line, and we'll see if it matches up. Okay, now I will tell you, we're not finding this at a specific point. We're going to find a general expression, but it's like any other function. If I want to know what's the derivative at x equals 1 or at x equals pi or at x equals, I can put that input value into the derivative, and I can find it, and we're going to do some of that. Okay, so here we go. Again, you need to write this down every single problem you work, because if you don't, you're going to come up to that test next Thursday and you're going to panic and you're going to forget. So please write this down. It's the limit as delta x goes to 0 of x plus delta x minus f of x divided by delta x. I guarantee if you write this for every problem as you start, you will not panic next Thursday. Okay, so our derivative is going to be the limit delta x approaches 0. Now here's where we have to understand our function notation. I'll put delta x down here, okay? And I can even go so far as to put in f of x. I know what that is, okay? I know that that is 2 divided by the square root of x plus 1. Okay, we all know that, right? So this is all right up here. We have to know, though, how to interpret f of x plus delta x. What's my input? And what do you do with an input? Everywhere you see the input in the function, you replace it. Okay, good. I know you gave me those right answers, so I'm going to accept them. Okay, so here we go. Denominator is the square root of x plus delta x plus 1. Now, this problem at this point is going to be nothing more than you using all of those algebra skills from Algebra 1 and Algebra 2 that you know of. In fact, even before algebra, because I've got two fractions with unlike denominators. I can't subtract unless I have fractions with the same denominators. We know that. Knew that since elementary school. So what am I going to do to add or to subtract these? Well, I've got to get the same denominators. What denominator am I going to use? What's going to be my common denominator? This is one of those problems that takes a lot of space, so we're going to give ourselves a lot of space. Who's watching the clock for me down here? Who's my resident clock watcher? Okay. So I'm going to watch that. When it gets to be about another minute, we're going to have to stop this. Okay, so here we are. My common denominator is going to be the square root of this quantity minus the square root of this quantity, which means that I'm going to have to use a common, I'm going to have to multiply this fraction by something. I didn't leave myself much room, and this fraction by something. And what am I going to multiply by? See if I can get that squeezed in a little better here. I'm going to have to multiply this fraction over here by what value? Yeah, square root of x plus 1. Is that it, Akeem? Divided by what? Well, you know, if I multiply by just that, haven't I changed the whole value of that first fraction? What's the only thing I can multiply by and not change the value of the first number? 1. So how does the fraction look if I want to have this fraction be equivalent to 1? Yeah, it's going to have it down there too. Okay, what about over here? I got to multiply that by something, and that's going to have to be the square root of x plus delta x plus 1 divided by the square root of x plus delta x plus 1. Okay, so I'm not going to do anything different than what I would do in arithmetic. Okay, so we're going to